Hi guys! Salamat sa inyong patuloy na ginagawang pagsubaybay dito sa ating discussions about statics of rigid bodies. Tayo ngayon ay nasa pangatlong problem na ng friction, kaya sana sa pamamagitan nitong problem na ipakikita ko sa inyo ay lalo ninyong maunawaan ang konsepto ng friction at paano ito ina-apply in solving engineering problems. Guys, ito yung problem. As shown in the figure, a homogeneous cylinder weighing 232 pounds rests on a horizontal surface in contact with a block which weighs 180 pounds. If the coefficient of friction F is equal to 0.4 at all contact surfaces, find the couple M acting on the cylinder which will start it rotating clockwise. Ipaliwanag natin guys ang problem, ano? So, in the problem, meron tayo ditong cylinder that rests on a horizontal surface and it is in contact with the block at this point. Ang weight ng cylinder ay given, which is equal to 232, while the block is also given. The weight of the block is 180. The coefficient of friction, ibig sabihin yung relative roughness of the cylinder and the block at this point is equal to 0.4. Ganon din ang relative roughness ng cylinder with the floor. It is equal to 0.4. Now, if the cylinder will be rotated by applying a moment or a torque, in this case, a clockwise moment, the question is how much is this M required to start rotating? So, kung mapapansin natin, there are two possible scenario kung paano gagalaw ang cylinder. At ipakita natin dito. So, here are the conditions of motions of the cylinder. First scenario is that pwedeng yung cylinder ay simply it will rotate in its place by sliding with the floor and the block. And the block will remain stationary. Iikot lang siya, no? Iikot lang siya in its station, okay, sliding against the floor and the stationary block. At ganito ang mangyayari kung gagalaw siya, no? Ipakita natin dito. So, pinalitan ko muna siya ng illustration para ma-apply ko yung animation. Here is what will happen to the cylinder and the block. Okay, when the moment is applied, the cylinder will simply rotate in its position. It will not be able to push, okay, the stationary block, and it will just be sliding against the block and the floor. Diba? The other condition is that the cylinder will roll on the floor and slide on the block. Gugulong ngayon siya, yung cylinder ay gugulong at habang gumugulong, mag-i-slide siya against the block na maitutulak ngayon yung block. Ibig sabihin, the block will be pushed towards the right. Ganun yung second scenario, no? So, sa mga katuwid, kung ipapakita natin dito, ganito yung mangyayari sa second case, ano? Ang mangyayari ay, magro-roll ang cylinder at habang nagro-roll siya, naitutulak niya ngayon ang block. Diba? Ulitin natin. So, ganyan yung mangyayari. Okay? So, di ba? So, paano natin ito sasabihin? How are we going to determine the moment that will start that motion? Ang first case ay, paano natin malalaman kung alin ba yung actual motion na pwedeng mangyayari dun sa cylinder? Ito baga iikot lang sa kanyang posisyon at habang gumugulong, may tutulok niya itong block na ito. Diba? Kaya, ang paraan ng pag-solve natin dito is, we try to consider one case or one scenario, okay, and then we check if the scenario will satisfy the conditions of equilibrium. So, kaya subukan natin na i-analyze yung cylinder natin as if it is simply rotating in its place and it will just slide against the floor and against this block. So, paano mangyayari yon? So, ang magiging assumption natin dito is that we will assume that the block is heavy enough that it cannot be moved by the cylinder when the cylinder rotates. So, magiging assumption natin dito is, okay, ito ay mabigat para hindi siya maitulak. Ano? Mabigat para hindi siya maitulak. At dahil mabigat siya, mangangailangan siyang lang larger force because there will be larger frictional force that will be developed between this block and the floor. Okay? So, tingnan natin, no? So, let us try to isolate muna itong free body diagram ng cylinder para maunawaan natin kung paano siya solve. So, kung in-isolate natin siya, pakita natin yung mga forces na mag-act dito. Una, at the center of the cylinder, meron tayong weight which is equal to 232 pounds. Pangalawa, at this point which is in contact with the floor, so we will expect that the floor will be exerting a normal force, and let us call that normal force be N sub 1. And because the cylinder will be rotating or sliding against the floor, so ipakita natin ito yung tinatawag nating sliding motion of this cylinder against the floor, or the relative motion of the cylinder against the floor. As such, itong floor na ito ay mag-exert ngayon ng frictional force against the cylinder, and the direction of the frictional force must be opposite the direction of this relative motion of the cylinder against the floor, and this is directed in that manner, and we will be calling it as F sub 1. And we know that because the coefficient of friction is equal to 0.4, then this F sub 1 can be expressed in terms of N sub 1 by the formula that F sub 1 is equal to 0.4 multiplied by N sub 1. Diba? Ngayon, itong cylinder ay may contact din sa block at this point. So, sa point na ito, mayroong ngayon force na i-exert ngayon ang block. Diba? And kay the magnitude of that, let us call that as N sub 2. And because this cylinder will be rotating in that direction, so ibig sabihin, ito yung magiging relative motion ng cylinder against the block. And as such, the block will be exerting a force or a frictional force in the opposite direction as the direction of the relative motion of the cylinder against the block. And therefore, it will be directed in this manner. And that will be our F sub 2, and that F sub 2 can be expressed in terms of N sub 2 because F sub 2 is equal to 0.4 multiplied by N sub 2. And because this is in equilibrium, then this must satisfy, ano? Wala pa naman kasing motion wala pang motion. So, pinakita kong paggalaw, impending lang yon. So, pinakita ko lang kung umiikot siya para makita natin o maunawaan natin ano yung magiging relative motion ng cylinder nito against the body with which this cylinder is in contact. But there is no motion yet. The motion is just an impending motion. And therefore, it is still in state of equilibrium. And therefore, it will satisfy the condition of equilibrium. At ano nga ba yun? So, pag in-apply natin ngayon, yung summation of force horizontally, horizontally, sa makatwid, pwede natin express ngayon yung N sub 2, itong value na ito, in terms of F sub 1. And that, by summing of force horizontally, that is equal to 0, and we treat K direction of the force to the right, be positive, our equation becomes F sub 1, this one, minus N sub 2 shall be equal to 0. And so, N sub 2 will be equal to F sub 1. Diba? N sub 2 will be equal to F sub 1. Furthermore, yung ating expression ng F sub 2, because F sub 2 is equal to F multiplied by N sub 2. If N sub 2 will be substituted with the value equal to F sub 1, then for our F sub 2 will be equal to 0.4 multiplied by F sub 1. So in this case, na-express natin ngayon yung F sub 2 in terms of F sub 1. Di ba? Ngayon, balikan natin dito, puntahan natin itong relation naman ng F sub 1. Di ba? Sabi nga kasi dito, yung relation ng F sub 1, which is this one, shall be equal to 0.4 of N sub 1. Sa makatwid, pwede nating i-express yung N sub 1 in terms of F sub 1. So that N sub 1 will be equal to F divided by 0.4. So, na-express na natin itong N sub 1 at saka itong F sub 2 in terms of the same variable F sub 1 and F sub 1 here. Now, if we're going to apply the other condition of equilibrium, that is summing up forces vertical equal to 0, and we consider the direction of force directed upward be positive, therefore our equation, our equation for the forces for summation becomes n sub 1, this one, plus f sub 2 minus 232 shall be equal to 0. Now, if we're going to substitute the value f sub 2, diba? Substitute natin yung the value of n sub 1, which is this one, which is f sub 1 over 0.4. At itong f sub 2 na ang value naman ay 0.4 multiplied by f sub 1 in this equation. Therefore, our equation becomes, okay, f1 over 0.4, which is equal to n sub 1, ano? Plus f sub 2 na ang value naman ay ito, 0.4, okay, multiplied by f sub 1 shall be equal to 232. Now, if we're going to simplify this equation, we can solve for f sub 1. And our f sub 1, therefore, shall be equal to 80 pounds. Sa makatuwid, asan itong 80 pounds na ito? Ito ngayon itong f sub 1 na ito. Ba? And that, okay, our f sub 2 will be substituted with the value of, okay, this one, 0.4 multiplied by f sub 1. And therefore, that is equal to 0.4 multiplied by f sub 1. Substitute natin yung value ng f sub 1, which is equal to 80. And therefore, our f sub 2 becomes 0.4 multiplied by 80. And that f sub 2 shall be equal to 32. Now, ipakita ngayon natin itong f sub 1 at f sub 2 in this FBD. Ano, ipakita natin yan. Ito ngayon yung ating f sub 1 na ang value ay 80 at itong ating f sub 2 ang value naman ay 32. Ngayon, sabi nga, for the cylinder to start rotating, diba? A moment that should be greater than the moment created by the frictional force that I have just simply substituted here. Kasi itong f sub 1 and f sub 2 magkakaroon ng tinatawag na resisting moment against rotation, diba? Which is counterclockwise in the direction, okay, counterclockwise in direction against this axis, about that axis. At ang sabi nga dito, for the cylinder to start rotating, a moment that is greater than the moment created by the frictional force must be produced. And therefore, okay, this moment must be producing, ano, okay, a greater moment than the moment produced by f1 and f sub 2 here. Now, but f sub 1 and f sub 2 have, okay, a moment arm equal to the radius of the cylinder, which is equal to 1.5. Similarly, ganun din ang moment arm itong f sub 2 about this axis of rotation, and that is also equal to 1.5 feet. Now, what will be the moment produced by f sub 1 and f sub 2? Okay, which shall be greater, no? So, the moment produced must be f sub 1 multiplied by r plus f sub 2 multiplied by r. And if all of those values are substituted here, ano ngayon yung ating moment na mapuproduce? That is equal to 80 multiplied by 1.5 plus 32 multiplied by 1.5, and the value of m will be 168. Ang ibig sabihin to, okay, kung iikot siya in its place, ang moment na dapat i-apply para umikot, para magkaroon ng impending motion na umikot, ay 168 foot-pounds. Pero, yun nga ba talaga ang kanyang magiging aksyon? Kaya magiging aksyon talaga bang iikot siya? Wala ba siyang tsansang maitulak naman yung block na nasa bandang kanan niya? So, ganito yung mangyayari, ano? Okay. So, ipakita natin. We check now the condition of the block if the block remains stationary. Subukan nating check-in. Mananatili ba yung block na stationary kung iikot ito? Bakit? Kasi meron kayong force na mag-act between the cylinder and the block, and that the block will be subjected, okay, to the following forces. Itong force na ito na tinutukoy ko. Okay, coming from, okay, the normal force that is exerted by the cylinder upon the block, and that value is equal to n sub 2. With the block weighing 180 pounds, di ba? Say, at this point, meron tayo ngayong, okay, frictional force na ma-develop, okay, which is equal to this one, and the value is 32. Diba? Sa makatwid, at the floor na kung saan the block is in contact, meron ngayong reaction na ini-exert ngayon ang floor, okay, which is directed normal, and we call this as normal or n sub 3. And there will be a frictional force that will be developed, okay, between the floor and the block, because the tendency of the block is to be pushed to the right by this normal force, and therefore there will be an impending motion of the block in that direction, directed to the right. Hence, the frictional force that will be exerted by the floor should be directed in the opposite direction as the direction of the impending motion of the block, which is directed to the right. Hence, the frictional force will be directed to the left, and we call this as F sub 3. Now, if we're going to solve K for n, then we sum up for the forces acting vertically. And we will be summing up force vertically, okay, assuming that direction force directed upward is positive, then our equation becomes n sub 3, okay, minus 32, this one, minus 180 shall be equal to 0. And so when we simplify, n sub 3 shall be equal to 212. Ito yun, yung 212. Now, we can now compute for F sub 3 dito, di ba? Compute natin yung F sub 3. So, solving for the maximum frictional force that can be developed under the block, yung pinakamalaki na frictional force before this will be pushed to the right. And that, we know that F sub 3 is equal to F multiplied by N sub 3. And that if we are going to substitute the value of N sub 3, which is equal to 212, therefore our value of F will be equal to 84. Now, let us try to compare with the maximum frictional force that will be developed, which is equal to 84.8. Ang ibig sabihin itong 84.8 na ito yung dapat na ito yung frictional force na pwedeng ma-develop bago siya gumalaw to the right. Eh, ang tanong, ano ba yung nagtutulak ngayon sa kanya in the rightward direction? Itinutulak ngayon siya nitong 80-pound force na nanggagaling mula sa cylinder. Ngayon ay ang tanong uli ay, sapat ba itong force na ito para maitulak itong block gayong ang frictional force na madedevelop kay between the block and the floor is 84? Diba? Ang sagot ay hindi, kasi malaki itong F sub 3 kay kumpara dito. Sa makatuwid, hindi kayang itulak nitong cylinder itong block na ito. And as such, ano ngayon ating maging conclusion? Ang maging conclusion natin ay the cylinder will rotate in its place and the block cannot be moved because there will be an 84.8 frictional force that will be developed before it can be pushed. And the only force that can be exerted by the cylinder upon this block is just 80 pounds. So sa mga katuwid, ano ngayon yung ating magiging kasagutan doon? Ang ating magiging kasagutan doon, yung maximum moment that will be applied will just be equal to the moment produced by this 180 and 32, which is equal to 168 foot-pounds. Ngayon, subukan nating solvin siya the other way. So, ipakita naman natin ngayon kung paano kung ang assumption ko ay gumalaw ang block. So, let us try to consider if the cylinder will roll on the floor and slide on the block. While rolling, the block will be pushed towards the right. Ipakita natin yung FBD. Ito ngayon yung kanyang free body diagram. So, itong block ngayon is subjected to force of 232. Ito naman ay merong weight na 180. Diba? So, sa block na ito, merong normal force dito na N sub 3. Diba? So, dahil ito yung kanyang motion, therefore, there will be a frictional force that will be developed here, which is equal to F sub 3, and the magnitude is equal to 0.4 multiplied by N sub 3. At the point where it is in contact with the cylinder, this point, merong force na mag-act itong ine-exert itong cylinder upon this block, and we call this as N sub 2. And that is the similar way, itong block naman ay meron din ine-exert dito na N sub 2 rin dito, di ba? And we have just computed the value of that. So if this is the impending motion of the cylinder against the block, yung frictional force will be directed upward, and we call that F sub 2. And therefore, ito naman will be subjected to a downward frictional force, and that is also equal to F sub 2, na kung saan ang value naman ay 0.4 multiplied by N sub 2. Di ba? Ngayon, ito ngayon yung sinasabi nating tendency kung siya ay gagalaw. Ang magiging galaw nitong cylinder naman ay to roll against the floor, and therefore the motion or the rotation will not be anymore at the center but at this point where it is in contact with the floor, and therefore there will be a moment here, at yan yung moment na hinahanap natin, diba? Yan yung moment na hinahanap natin. So it will be subjected to a normal force here, and there will be a frictional force that will be developed there. Ngayon, balikan natin itong block. Balikan natin yung block, ano? We're going to consider the FBD of the block. Ba? And then we apply the summation of force horizontal. Ba? Anong equation meron tayo? Assuming natin ng rightward direction is positive, ang ating equation becomes n sub 2 minus f sub 3 will be equal to 0. Ito yon at saka ito. So that n sub 2 will be equal to 0.4 of n sub 3. Kasi yung f sub 3 natin is equal to 0.4 of n sub 3. Hence, n sub 2 is equal to 0.4 of n sub 3. Now, if we're going to substitute n sub 2 in f sub 2, ba? Dito yun, ano? Yan, dito yun. So, sa makatwid, ang ating maging equation will be f sub 2 will be equal to 0.4 multiplied by the quantity 0.4 multiplied by n sub 3. And this will be equal to how much? 0.16 n sub 3. Ito ngayon, express na natin ito. Now, if we are going to apply ngayon, summation of force vertical equal to 0, and we treat that force directed upward will be positive, what will be our equation? We have n sub 3, which is 1, minus, f sub 2, minus 180 shall be equal to 0. But what is f sub 2? F sub 2 is equal to 0.16 n sub 3. So that if f sub 2 will be substituted with this value, I will have n sub 3 minus 0.16 n sub 3 shall be equal to 180. And then simplifying, we can solve for n sub 3, which is equal to 214.2857. Ito ngayon yung n sub 3, di ba? Sa makatwid, yung ating f sub 3 will be equal to 0.4 multiplied by n sub 3. That is 0.4 multiplied by 214.2857. And therefore, our f sub 3 will be 85.714. Ang ibig sabihin to, 85.714 yung force na ma-develop ngayon dito. Ano? Ma-develop ngayon dito. Ngayon, i-apply natin. What will be our n sub 2 therefore? Ang n sub 2 will be equal to f sub 3, and therefore, this will also be equal to 85.714. Ito nga yung ating f sub 2. Diba? Ngayon, what about our n sub 2? What about our n sub 2? Our n sub 2 is here. Diba? Our f sub 2, our f sub 2 is 0.4 multiplied by 85.714. So, makatwid yung ating f sub 2 will be 32.29. Diba? So, makatwid, kung ipakikita natin yan, we're going to consider the FBD of the block. Balikan lang natin itong block na ito. Ipakita na ngayon natin itong n sub 2, which is 85.714. At ipakita rin natin itong f sub 2 na na-compute natin at 32.29. So, this is still in equilibrium. However, there will be a impending rolling motion. At ang rolling motion will be, it will be rotating about this point A. Diba? So, if we're going to take moment about A, ano ngayon ang ating ano ngayon ang mga forces na mag-create ng moment about A? These two will not create moment because these two will pass through A, as well as the weight of the cylinder. The only forces that would create moment will be F sub 2 and N sub 2. Diba? And both will be creating a counterclockwise moment. Now, in order for this to be rotated or to start motion in the rolling direction, then the moment that will be produced by this must be counteracted or must be exceeded by the moment applied at this one, and that is the moment. And the moment will be equal to, tingnan natin yung kanyang momentum, ano? Sabi nga kasi dito, the cylinder will have an impending rotating motion about A if the applied moment is equal to the moment produced by F sub 2 and N sub 2 about A. Thus, the moment will be equal to F sub 2 multiplied by 1.1 plus n sub 2 multiplied by 1.5, so that if this will be substituted with the value, the moment that will be produced will be 177.0. Ngayon, balikan ko yung kaninang moment natin, ano? Yung moment na kung ito ay magro-rotate in its place, yung moment na nasolve natin ay 168. At ngayon, yung moment na nasolve natin dito is 177. Now, using these two possible values of moments, ano yung ating magiging conclusion? So, conclusion natin dito, since the moment required to cause rotation of the cylinder in its position is less than the moment required to cause the cylinder to move the block, then the required moment to start rotating the cylinder is 168 foot-pounds, and the tendency of the motion is that it will be rotating in its place. Okay, sana guys ay naintindihan, nasundan niyo yung ating ginawang discussions about this problem. Sana nakatulong sa inyo na lalo ninyong naintindihan ang friction, so that when you encounter a similar problem in the future, you can solve the same problem. Hope guys that you will continue following our discussion by subscribing to this channel and sharing to your friends for them to be informed also of my future uploads. Thank you very much for watching.